In this video lecture, we're going to discuss how to derive a Boolean equation from a truth table. We could derive both SOP and POS in a truth table. It depends on the output that we're going to consider in deriving the equation. If we want to derive the SOP, we're going to consider all input that give us an output of 1. So for example, this truth table give us this set of output. So deriving SOP, consider all input that give us an output of 1. So which are 0, 0, 1, 0, 1, 1, 1, 0, 1, and 1, 1, 1. So now the problem is how we're going to convert this input to its equivalent product term. Yes, we're going to convert input to its equivalent product term. So for example, the first set of input that give us an output of 1, which is 0, 0, 1. So we're going to get the product of this ABC. But unfortunately, if you're going to get the product based on the given input, the result is 0. So therefore, we need to introduce a function wherein if we're going to AND A, B, and C, it will give us an output of 1. So in getting product term, we're going to negate all input, which is equivalent to 0. So therefore, both AB will be negated. So A naught, B naught, C. That will be the equivalent product term of 0, 0, 1. So when you substitute this input to A naught, B naught, C, it will give us an output of 1. So that's why we negate input 0 when we get the product term. So how about the second, 0, 1, 1? Negate A. BC unnegated. So the result will be A naught BC. How about the third term? 1, 0, 1. B is complemented. So therefore, the result is A, B naught C. While the fourth is 1, 1, 1, therefore, there's no uncomplemented variable. Therefore, the product term is A, B, C. Then after getting the product term of all input that give us an output of 1, now we could get the SOP. So just or all the product term, that will be our SOP. So this is the result. A naught B naught C plus A naught BC plus AB naught C plus ABC. Okay? So now, how to derive POS? So now, instead of considering 1, we're going to consider 0 output. All input that yields an output of 0 will be considered in our POS. So which are 0, 0, 0, 0, 1, 0, 1, 0, 0, and 1, 1, 0. So now, how could we convert ABC to its equivalent sum term? So we're just going to add the input and it should give us an output of 0. So A plus B plus C for this second set of input that yields an output of 0. So A plus B plus C. But the problem here is we have 1, which is B. Therefore, when we add 0 plus 1 plus 0, it will yield an output of 1, which is incorrect because it should be 0. So if we have this scenario wherein it will give us 1 and supposedly it should be 0, we need to complement the input that has an output of 1, which is B naught B. So it will be B naught when we write it. So the result will be A plus B naught plus C for 0, 1, 0. So how about 0, 0, 0? So just A plus B plus C. How about 1, 0, 0? So we have 1 here. So therefore, we need to complement it so that when we add A, B, and C, it will yield the 0. So The equation, the sum term, is equivalent to A naught plus B plus C. And last, 1, 1, 0. So we're going to complement A, B, and complement C. So A naught plus B naught plus C. That will be the equivalent of 1, 1, 0. So now we already derive the sum term of all input that yields an output of 0. So to get the POS, just and all this and all of the sum term. That will be the POS. So this is our answer. So that's how easy to derive POS and SOP in a given truth table. So thank you for listening. See you on the next video lecture.